Greetings for the day, students. In the series of the lectures which we are discussing here, another video lecture on types of graph is being discussed here, presented to you. Okay, so first of all, we will see the types of graph: directed and indirected graphs. The graphs are basically of two types: directed and undirected. It's the best understood by the figure given below. See here that in the figure in which I have annotated nodes with green, and there is an arrow for each of the edge joining these vertices, that is three vertices. Arrow starts at one vertex and ends at the other. So it is called a directed graph. Now, undirected graph, the edges have no such direction, no such arrows, and the traversal in this case can be on both the side, that is from any of the vertex. And here the undirected graph is shown by the vertices having red color. Okay. So next, another type of graph is a null graph, a graph in which there is no edges, there is only vertices as here shown A, B, C. First one, the null graph, that is, then there is no edge connecting these vertices or nodes from one to the other. Now, another form of graph is a simple graph, a graph that is undirected and does not have any loops or multiple edges are called simple graph as shown here in the given example. A graph given here is a simple graph. Then multigraph. What is a multigraph? A graph with multiple edges between the same set of vertices, and it is called a multigraph or loop is formed. Now another form of multigraph is a pseudo graph in which the vertices have got self loop. That is, the vertex traverse to itself. So these type of multigraphs are called pseudo graphs. Then comes connected graph, a graph where any two vertices are connected by a path. For example, here we see that a connected graph in which A, B, C, D, E is the vertex. If we want to move from any of the vertex to the other vertex, there is a path in between. Such type of graph is a connected graph. That is, if we want to move from A to E, vertex A to E, then from A we move over to B, from B we move over to C, from C we move over to D, and from D we move over to E, and through a path there is a path between each and every vertex. So of a graph, such a graph is called a connected graph. Now disconnected graph, a graph where any two vertices or nodes are disconnected by a path, that is, there is no path between any of the two vertices as here shown in the diagram, that one portion of the graph is not connected to the other portion. Such type of graph is a disconnected graph. Then comes a cycle graph, a graph that completes a cycle. We have discussed in the previous series of lecture that what is a cycle, what is a circuit. So you must be aware. If you are not, then you can go through that lecture. That a cycle is basically when we traverse through all the vertices and reach to the same vertex. That is, starting and end vertex is same. Then it is called a cycle. The cycle graph is a graph that completes a cycle. Then comes a complete graph. When each pair of vertices are connected by an edge, then such a graph is called a complete graph. Now, what is a complete graph? That, for example, if we take a vertex here, this vertex, then it has got connection or path, direct path for to each and every vertex of the graph. See here, basically, there is a formula for this. If there is n vertices, if there is n vertices in the graph, then number of edges which are there is, suppose there is n vertices, uh, n vertices in the graph, then how many edges are there? n n into n minus 1 by total divided by 2. So this number of vertices. So for a complete graph, if there is n vertices, then number of edges in that graph is n into n minus 1 by 2. Okay. So then another form of graph is a planar graph. Now what is a planar graph? A planar graph is basically a graph. Planar graph is basically a graph in which no two edges of the graph intersect and are all edges and vertices can be drawn in a single plane. Then the graph is called a planar graph. Now, we will again when we will move over and see what is Euler's graph, then we have got a formula for Euler planar graph. So first we will see what is the Euler graph. In another lecture, another video lecture, I will be explaining you what is Euler planar graph and we'll be doing some of the numerical examples on that. So what is a planar graph? When two edges of the graph intersect and are all the vertices and edges such that they can be drawn on a single plane, then such a graph is called a planar graph. And what is a bipartite graph? That is very important types of graph and lots of numerical questions are asked upon it. So when we have got vertices or nodes in a graph. Now when we take these vertices and forms two distinct sets or disjoint sets such that the starting of the edge belongs to the one set of vertices and end of that edge belongs to the other set of vertices and both the set of vertices are disjoints to each other, then that type of graph is called bipartite graph. So here the definition is written. Vertices can be divided into two disjoint sets such that no two vertices within the same set are adjacent. In other words, it is a graph in which every connects a vertex of one set to a vertex of the other. Now, for example, as we see a different color, the green colored vertices belong to set V1 and the orange color or yellow color vertices belongs to set VT. So one set contains two vertex and other set contains three vertex. So it is a bipartite graph. Now we come over to what is an Euler's graph. Euler's graph, all the vertices of any connected graph has an even degree. Then this type of graph will be known as Euler's graph. In other words, we can say that a graph is a type of connected graph which has got a Euler's circuit. That is, in Euler's graph, vertices can be repeated, but edges is not repeated. For example, here the given graph is a Euler's graph in which Euler's circuit is created. Now here see, when we start from B, we go to A, then from A we go to C, then from C we go to E, from E we go to D, from D we go to C, and from C we go to B. Here we see that in this graph we have included all the edges of the graph only once and they form a Euler's circuit this way. Then this type of graph is called a Euler's graph. So we can say that this graph is a Euler's graph because it contains a Euler's circuit. In this thing is to be noted that uh, vertices are of almost even degrees. Then they can form a Euler circuit. Then another form of graph is a Hamilton graph. Now in Hamilton graph is that when we walk through the vertices, then all the vertices appears in the walk only once, except for the starting and ending vertex. So a graph will be known as the Hamilton graph if there is a closed walk uh, between there is a closed walk in a connected graph which passes each and every vertex of the graph exactly once except the root vertex or the starting vertex. Root vertex basically root is the starting point of the traversal. A connected graph, it is if there is a walk that passes each and every vertex of the graph only once, and after completing the walk, return to the starting vertex, then this type of walk will be known as a Hamilton circuit. Okay, so basically, what is a Hamilton circuit? In which all the vertices except the starting and the ending vertices are not repeated, and all the vertices are included in the walk, then that type of circuit is called Hamilton circuit, and the graph that contains Hamilton circuit is the Hamilton graph. So these are the references through which I have planned out this video lecture. Thank you, students.